Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken some test questions which are based on absolute value functions. Express using absolute value function and graph on a number line. So we have 6 examples here. The very first one, x is between -2 and 2. X is less than equal to -5 or x greater than equal to 5, x not equal to plus minus 6, x not equal to 5, x is greater than equal to -2 but less than equal to 6, and x greater than equal to 1 or x less than equal to -7. You can always pause the video, answer these questions. The last two are kind of challenging questions seen in many test papers. We'll see how do we answer them one by one. The very first one is straightforward. X is between plus and -2. You can write this as an inequality, absolute value of x less than 2. So that really means that the value of x is between two numbers, and these two numbers are -2 and 2. 2 and -2 not being included. So on a number line, you represent as shown here. Clear? The next one is x is less than equal to -5 or x is greater than equal to 5. It means away from. You get the idea, right? So here it is absolute value of x is greater than equal to 5. So it is away from. So in this particular case, on a number line, what you notice is that the arrows are pointing away from the numbers -5 and 5. Makes sense? Since it is greater than equal to, they will be also filled in. So when we fill in, we include the numbers at the boundary. Perfect. So I think to begin with, these two are straightforward, which give you the definition of absolute value function. Now let's move on. We have x not equal to plus minus 6. How do we write this as an absolute value function? So when I say x is not equal to plus minus 6, then it means we are looking for two values where x is not equal to plus minus 6. So we could say that absolute value of 6, x is not equal to 6, correct? So that really means that two values are excluded because minus 6 will also be absolute value as 6. So that is clear. So on a number line, we are going to represent this as not equal to plus and minus 6 means everything but not plus and minus 6, right? So in between them and away from them, all will be highlighted on a number line. X is not equal to minus 6 and x is not equal to plus 6. That is how you're going to show it on a number line. So far, so good, right? So whenever we are using absolute value function, normally we have two limits. Either it is within those things or it is away from them or at those or not at those, right? Now here is a unique example where we have x not equal to 5. Not equal to 5 is just one value, right? So how do I write it as an absolute value function? Well, on a number line, it is simple. I could say everything but not 5, right? So everything but not 5 means we have arrows on both the sides from 5, correct? But 5 is not included. So writing it on a number line is not a problem, correct? How do I represent it on a as a absolute value function? Well, that is kind of difficult. So, well, as you know, if I write kind of like this, absolute value of x minus 5. So what is that equal to? Well, the absolute value function has moved 5 units to the right. And if I say that this is greater than 0, in that case we are excluding x equals to 5 because at 5 the value is 0. You get the whole idea, right? At all other places it is positive value. So that becomes the absolute value function inequality to represent the situation. Clear? Great. So that brings us to the last two questions where we have x between minus 2 and 6, both are included. So on a number line, let's get those marks first. We have the 2 points, minus 2, right? And 6. So everything in between, including minus 2 and 6, will fill this up, right? Correct. Now, how do I write absolute value inequality when the two numbers are different? So that is very interesting to understand. So I'm going to share with you a tip here, and that is find the midpoint. So what is the midpoint? So midpoint will be add them, divide by 2, right? So if I add 6 and minus 2, I get 4, divided by 2 is 2. So the midpoint here is 2, right? Now, from 2, how far away are these 2 points? So we can see that from 2, this is 4 units, right? 2 to 6, and this is also 4 units, right? So we can see that they are 4 units away. So if I position the absolute value function right at 2, which is to say absolute value of x minus 2, right? And then what I want is that this value should be within 4 units and equal to also because the endpoints are included. Do you see how beautifully and easily we got our solution, right? So that is how we have done this. And now the last question for you is very similar. So I like you to adopt this strategy and do it yourself, right? So we have this number line, and on a number line, we know that x is greater than 1 means, let's say like this, right? Greater than equal to will fill it up, and less than equal to minus 7, less than equal to fill it up. This is minus 7, that is 1. I like you to do this question yourself. Strategy is very simple. First step, find the midpoint, right? Find the midpoint and then see how far are you from the two ends. Makes sense, right? So I like you to do it yourself, take it as a test question, and then move on to the next video. So, in this series, we have taken some beautiful questions which will help you prepare for a test on absolute value functions. I hope it helps. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. In case you want to learn directly from me, you can always send an email on globalmathinstitute at gmail.com. Thanks for your valuable time and all the best.